Okay, good morning. So if you remember last time we started talking about angles in the circle, we talked about two types of angles. One angle was called, what do you remember? Central angle. And the other one was inscribed angle. And then there was one important theorem going on there, and that was the case that if I have a circle and this is the center, if I draw these two lines, this angle that it is constructed here is called a central angle. So let me show it with X. And this arc opposite to that is the arc subtended by X. And then we learn that if I have an inscribed angle means that the vertex is on the circle and the arms are chords of the circle. But if this is in a way that it also subtends the same arc, yes, and then if this I call it y, we learn that there is a relation, a very nice relation between the size of x and the size of y. And what was that? Yes, what? Yes? Yes, x is 2 times y. There were some consequences of this. We explored them. Today I want to go to, and we solved some level 1 problems from the book. But now we want to start working on a little bit higher level problems here today. And if we have time, we continue the lesson. Otherwise, we continue next time. So I want to wait for you so that you yourself can solve these problems first. These are level 2 problems in the book. They are not level 1 problems. Okay, so I want to wait a little bit for you so that you can work on yourself to see if you can find what is wanted in these problems, and then we continue together. Yes, please do that. Don't waste your time. The exam is close. Okay, to refresh your memory a little bit, let us solve this problem together first. I think it's very simple. It's not hard. Yes? So, for example, if I ask you what this angle V is, the answer should be simple. What is that? You need to ask yourself, what type of angle is this? What is that? Because the vertex is on the circle and the arms are chords. So V is an inscribed angle, yes? V is inscribed. But if I ask you what the type of angle is this angle, it will tell me because the vertex is the center and the arms are radii, so this is what we call a central angle. If I ask you what is the arc subtended by the inscribed angle, in other words, what is the arc opposite to this angle, I hope that you agree that this is the arc subtended by angle V. Agree? Okay. If I ask you the same question, what is the arc subtended by this central angle? It starts from here again to here. So the same red arc will be subtended by this central one as well. So that's exactly the theorem. I have an inscribed angle, I have a central angle, and they are both subtending the same arc. If this happens, we know that the central angle is 2 times larger than the inscribed angle. Yes? And then I'm looking for V, so I divide everything by 2. 230 degrees divided by 2. So V is what? 115 degrees. So, but you need to train your eyes to catch the pattern. I mean, they intentionally sometimes make the problem a little bit complicated, but you need to train your eyes to be able to catch the pattern, yes? So that was easy. Okay, what can I do for you? There are 2 things you can do for you. Both of them are acceptable in the exam. Either, do you remember, if you look at this whole shape, the name of this shape is a quadrilateral, and then all the vertices are on the circle. So we learned that from Math 1C that the sum of the angles of any quadrilateral is 360 degrees. But we learned something more about quadrilaterals whose vertices are on the circle. I gave it a name. There is a name for it. This is called a cyclic. a quadrilateral, but you don't need to know the name. So in the cyclic quadrilateral, what we know more is that the sum of the opposite angles should be 180 degrees. So what I can write is that U plus V should be 180 degrees. V is already found. So what happens? I put it here, and then I look for U. So it is very simple. U is this number minus that number, which is 65 degrees. This is one way of doing it, and it is acceptable. So, but in the exam, you would say that this is a quadrilateral, a cyclic quadrilateral, so the sum is 180, and then the rest of the calculation. You might not do this. You might say that, okay, if this is 230 degrees, I know what is this one? It is 360 degrees minus this number. So 360 degrees minus 230 degrees. What is the answer? 130 degrees, yes? So this angle is easy to find. But again, if you compare U and this angle, U is inscribed because the vertex is on the circle. O, this O you see here is central. And both of them are subtending this black arc. So this is inscribed subtending the black arc. This is central subtending the black arc. So the size of the central one is 2 times larger than the size of the inscribed one. So what do you write? You would write 130 degrees is equal to 2 times U. And then because you are looking for U, you divide everything by 2, it becomes 65 degrees, which is exactly the same answer you got there. I myself prefer to do it here like that, that is simpler, that's up to you. So for finding V, we did it in this way. For finding U, you have 2 alternatives, either use it like this or do it like that. Yes, is that understandable? So these are level 2 problems according to the book. Okay, so that is a refresher. I hope that now you remember what probably we had in the previous lesson. Now I want you to concentrate again. Everyone concentrate here. Might be this looks a little bit simpler. So you see this AB and AC are tangents. This is a tangent line. Tangent means it touches the circle, does not cut it. Yes, because you know that if I have a circle and I have a line, sometimes this line has nothing to do with the circle. Okay? Sometimes it cuts it at 2 points. This is called a secant. Secant means the line that cuts the circle at 2 points, but sometimes it just touches the circle. Yes, and that is called a tangent. Okay, and then they haven't mentioned this here, that this is the center. So let me call it O as the center here. So there is a theorem that if you have a line tangent to a circle, if you take this point at which the line touches the circle and connect it to the center of the circle, it becomes a radius, of course. But there is a theorem that tells you that this radius that you generate in this way always is perpendicular to the tangent line. In other words, this angle is 90 degrees. Okay, so if we know that, then it is very simple, yes? It has nothing to do with these rules, because they are telling you this is the tangent line and this is the radius. Touches actually this is the tangent point of tangency, which is connected to the center. So this angle, without telling you, you need to know yourself that this is 90 degrees. And the same story happens here. That is also 90 degrees. I want to see if we can solve this problem independent of this piece of information. because they haven't mentioned this in the book. But if, let us say that you know that, of course, this in my exam you can use it, then I will think about how we can solve the problem independent of this. This is extremely important. So remember, if you have a circle, and if you have a tangent line, it doesn't matter where it is, tangent. So let us take this one. And then the tangent line touches the circle exactly at one single point. If you take that point and connect it to the center of the circle, you make a radius. That is clear. Yes? You make a radius. That radius that you generate in that way is always perpendicular to the tangent line. Yes? If we take this for granted, then because it is mentioned in the problem that these two lines are tangent lines to the circle, because of that, I understand myself, even though it is not mentioned in the picture, I understand myself using this theorem that these two angles are 90. And then I can immediately find alpha because OCAB is a quadrilateral. It is not a cyclic quadrilateral, so I am not allowed to write alpha plus this is 180 degrees, yes, because this is not cyclic. This vertex and that vertex are not on the circle. But then I know that in any quadrilateral, the sum of the angles should be 360 degrees. So this one is 67 degrees, plus this is 90 degrees, plus this is my alpha, which is not known, and this is again 90 degrees, and this is supposed to be 360 degrees. 90 and 90, 180, 247. So alpha plus 247 degrees is equal to 360 degrees. And then you write alpha equals to, you move this to the other side, which becomes what? 113 degrees. This is correct. But I don't know why they have mentioned, usually if you are a mathematician, you are not allowed to use the pieces of information which is not provided for you. Okay. I want to think, if do you know how we can solve the problem independent of that? Yeah, I think it should be possible. But now you understand that I will come back to think about how we can solve this problem. But if you use this fact, it's a very well-known fact. I don't know why it is not mentioned in your book. But that is extremely simple and important fact. You can use it in the exam. But you go to the other one, try to solve the other one. In the meanwhile, I will think if there is any way that without this piece of information, we can still solve the problem. Problem, if you are comfortable, you can use this fact. Okay? If you use that fact here, the problem becomes again simple. But I want to know how we can do it without using this fact. Okay, I checked the solution manual. They are using this, but I don't know. In principle, when you want to use, have you studied this in Grundskolan, Manfred? Okay, so this is a little bit weird because when I check the solution manual, they are saying that this is always the case that this is 90 without even talking about it in the lesson. Okay, we know it, okay? So whenever you have a tangent line, and then take the point of tangency and connect it to the center, you make a radius. Out of infinitely many radii that you have, you generate one of them. That one is always perpendicular to the tangent line. So remember this fact as well. Okay? So now, this was very simple. This is also the same thing, a little bit more complicated than that. So whenever they talk about tangent line, you not only need to remember the information I gave you in the previous lesson, but you also need to remember this piece of information now. Okay, so now how can we solve the problem? Yes?
The second one.
Yes.
You connect the point B and point C to the middle.
Yes. And this is not called middle in English, center, yes?
Center.
Yes, and then?
You know that the two angles, down and up, they're
90 degrees. So for example, not to mess up, let me say that this is 90. Of course, this means the next one is also 90, and this one is also 90. Why is that? Because it is mentioned in the problem that this is a tangent line, and that's also a tangent line, and that is the tangent radius. The tangent radius is the radius connecting the center to the point of tangency of the tangent line. Okay, then what?
then you know that the smaller angle in the middle is 100 degrees, because on the other side there's 80 degrees, and 80 plus the angle in the middle is 180.
No, be careful, don't use it. This is by coincidence through here.
Yes, I know.
Okay, but then don't use it, because you see when you say that this angle plus this angle, so let me call this angle to be beta. So I understand, and that what you are saying is true. If you write 80 plus beta is 180, why is that?
Because those two up and down.
Okay, so you write this down, because if you just write this plus that is 80, people think that you are mistakenly using the cyclic. Yes, it's not cyclic, yes? Why it is not? It is a quadrilateral, I agree, but that is not a cyclic quadrilateral. Why? Because one vertex here and one vertex here are not on the circle. Okay, so the reason that still this plus this is 80, 180 is because of something else. Because of what? Because we know that the sum of the angles, beta, plus this angle, which is how much? 90, plus this angle, which is 80, plus this angle, which is again 90, is supposed to be 360 degrees. And because 90 plus 90 is 180, when I move it here, it becomes 180. So what you said is completely correct. So this becomes 180 minus 80, which is what? 100. Agree?
Yes.
360 degrees minus 90 minus 90 minus 80 becomes 100. So beta is 100 degrees. But my goal was not to find beta, my goal was to find alpha.
So
Can I use the cyclic quadrilateral here now? Yes. You know, that's why I'm saying that. You see, now you have a cyclic quadrilateral. I'm sorry. No, sorry. This is not a still a quad. Is it? It is not. Yes, because three vertices are on the circle, but one vertex is not. So still we cannot use that. Okay.
So you can do 360 minus 100 to find out the angle on the other side.
Exactly. So let us call this gamma. Yes. What type of angle is gamma? You name it. We have two names. Learn it. Central, inscribed. Which one is that? Central. No, it is central because the vertex is the center. What is the arc subtended by gamma? This blue one. This is the arc subtended by gamma. And what is the name of this angle alpha? Inscribed. And what is the arc subtended by inscribed alpha? The same blue one. So one of them is inscribed, one of them is central. Both of them are subtending the same arc. So the theorem tells me that what? Alpha times 2 is gamma. Yes? But what is gamma? Gamma itself is 360 degrees minus beta. But I know beta, so 2 alpha becomes 360 degrees minus 100 degrees. It becomes 260 degrees. So the alpha that I am looking for is 130 degrees. So you see, the problems are not that easy if you don't train your eyes. It is not that easy to detect the pattern. But I hope that you are now able to see what is happening. Yes? Okay. So let us go to a little bit, let us practice a little bit at level 2 problems first. I don't know what has happened here. Okay, so let us see if we can solve this problem. Okay, so it might be a nice problem. Yes, I want to wait for you. Problem 4210. We are supposed to use the information on the picture to find angle U. I think it's a good problem. I want to wait for you to solve it. If they say determine, might be they want a number because no numbers are given here. but we had something in the previous lesson. I hope that you remember. Yes?
I think I got
So what the answer is? 30. 30 seems right, but I want to wait for others as well. Don't give up. Try to work it out yourself. So, anyone else wants to describe this? Yes, Omar?
You can draw a line from
Let me give them names.
what is that in the
A.
oh yeah you can draw a point you can draw a line from A to center and that will give us radius
That is also how much?
radius
So radius means this is also R.
yeah
Yes. So this is already R because that's the center. This is a point on the circle. That is also R because that's a point on the circle. This is center. This was not guaranteed to be R, but it is given by the problem to be R. So we couldn't guarantee that that is R. We could guarantee that these two are always R, but not this one. This is guaranteed by the problem itself. Okay, then?
and then we know that a triangle
Yes.
that is equally
This is called equilateral.
exactly
So it means that all of them are the same. So it means all angles are also 60. So for example, all of them are 60, but we don't care about all of them. We care about this one. This is also 60 degrees. But then why U is 30 as Hasbulat mentioned? Yes, because this angle 60 is what is the type of this angle? What is the name? Central. Why? Because the vertex is the center and the arms are radii. What type of angle is this angle? It's an inscribed one because this vertex is on the circle and this line is a chord. This line is a diameter, but diameter is also a chord. So that's an inscribed angle. What is the arc subtended by 60 degrees? This red one. And what is the arc subtended by this inscribed one? The same. So inscribed, central, both of them subtending the same arc. So 60 should be 2 times U. So this means U is 30. Yes.
I did something else but still got that right
Yeah, that is also working. Yeah, you can mention that. You can say that if this is U, yes, this one is also U. Yes? Because this is an isosceles triangle. This is radius and that's radius.
yes I did that
And then you use this one. That also works. Yeah, of course, if you write that, that's also correct. Okay, so now this is some examples of level 2 problems. Let us go and solve some level 3 problems. I want, of course, wait for you. So I want you to do this level 3 problem. This seems to be a good problem. Yes? Determine the length of AC from here to here if we know that AB is tangent to the circle. So you need to probably use this property that I just mentioned. And of course, for some reason, the book has mentioned it to be level 3 problem, so there should be a reason. I want to think yourself about it. Because there is no lesson that I can teach you. You need to be able to use the information that I told you in the previous lesson and today to be able to solve this problem yourself. Yes.
you see it says 5 centimeters
Yes, 5 is the radius.
oh
Yes, from the midpoint. Yes, because they put it there. Yes, so when they say 5, my impression is that they mean from here, the center, to here. So consider this 5 centimeter. Don't make the problem complicated. It's not complicated at all. So you see what you want. You want from A to C. So what is the first impression? What do you want to do to find the length of AC? Of course, this part of AC is 5 centimeters. There is another part that you know. What is that part? from here to, let me call this one for you D. So this is 5 centimeters plus another 5 centimeters. So your problem is to find AD. Okay? Because if you know AD, then from here to here is 10. If you know AD, you add that AD to 10, that would be your answer. So try to focus on some goal, if otherwise randomly doing things is not good. Because how many things you want to do randomly? So now you understand that if I call this length x, if I find AD, then I am done. This is one strategy. I'm not saying that this is probably a good one, but that is one strategy. You should have a strategy, be able to follow something. If it's a strategy fails, then you just change your strategy. But you have to have a strategy. Otherwise, you just do things randomly. So you see, in this problem, you are not supposed to find an angle directly, at least. You are supposed to find a length. And the length theorems are not the theorems we had here. The length theorems are either Pythagoras theorem or I don't know, similarity theorem or something like that. Okay?
You don't have to use that, right?
So you have to find a way to use them because the theorems in this topic will only give you angles. But what is demanded is not an angle, it's a length. So somehow you need to think along these lines. That is, I'm telling you how to think about the problem. I'm not telling you that it will solve your problem, but it becomes simpler. Yes?
I got approximately 14.4.
Okay, just tell me your solution. What did you do?
So from the middle,
Yes.
draw a line to B.
So let me call it O. To draw a line to B.
Yeah, so I know that that angle there is 90 degrees, right?
This angle.
Yeah.
Yes. Why? Because of what we just learned today.
Yeah.
Why is that? Because this is the point of tangency. This is the tangent line according to the problem. I am connecting that point to the center. I am generating a radius, but that radius is always perpendicular to the tangent line. So yes, this angle is 90 degrees.
Yeah, and then from B to O, that's 5 centimeters.
From B to O is also 5 centimeters.
Oh no, I'm talking from B to the center.
Okay, B to O is also 5 centimeters.
Yeah.
Why? Because that is a radius, that is a radius, that's a radius. The radii should be of the same sizes, yes? Yes?
Then I used Pythagoras theorem to find the length from A to O, and then added 5 to it, and then got the answer.
A to O.
Or
Yes,
A to
yes,
C,
yes,
and
yes,
then
that's
I
exactly-
found the length and
exactly.
then added it.
Well, that's it. So I don't know why they call it level 3 problem, but this is your right angle triangle. Do you agree that AO to power 2, yes, the hypotenuse squared is AB to power 2 plus BO to power 2, yes? But AO to power 2, in my way of writing, I can, instead of AO, I can write x plus 5, yes? To the power of 2. This is AO. AO is x plus 5 is equal to, what is AB? 8 to power 2. What is BO? Is 5 to power 2. And then this is algebra. This is no longer geometry problem. It's an equation, it's a very simple one. I raise it to power 2 using the squaring rule. The first one squared, 2 times the first one times the second one. The second one squared. On the right hand side I have 64 plus 25. The good news is that this 25 and that 25 are cancelled, but you know that's a quadratic equation, so you have to use ABC or PQ formula. So I move this to the other side. Yes? You have questions? Ismail? Yes? You have questions? What? Okay, when you come late, that is the problem. Yes? I just told you that once more. If you have a tangent line to a circle, if you take that point, which is the tangency point, and connect it to the center, it makes a radius. This is always 90. This is a theorem which is unfortunately not mentioned in the book, but they are using it. So you need to be able to know that. So that's the reason that's 90. Okay, now we solve this problem, but because this is already 1 and this is even, I would prefer to use a PQ formula. Yes, I told you that whenever this is 1 and this is even, PQ formula is better. So what should I do? X becomes minus P divided by 2. This is my P in PQ formula, so divided by 2, it becomes 5 with a negative sign, plus or minus the square root of this number to power 2, but minus Q. Minus 64 becomes 64. So the answer becomes minus 5 plus or minus, what is this number? 89. But the square root of 89 is not a friendly number. But I need to know which one is acceptable, because x cannot be two numbers. Which one is not acceptable? The minus one, because this is already minus. If I choose the minus sign, it becomes a bigger minus number, which is not acceptable for the length. So this means that the minus sign is not acceptable. Is the positive sign acceptable? Yes, because the square root of 89 is bigger than 5. When I subtract 5 from it, it is still positive. So the answer that I want you to write in the exam, especially if the calculator is not allowed, is just this number. And then you write centimeters. But if I give you access to calculator, I might ask you to give me this number up to 1 decimal point, to 2 decimal points, then you use the calculator. But this, for this exam, if the calculator is not allowed, that is even better. Just write it like this and leave it. So is that clear? So I don't know, they call this level 3 problem. Let us do one level 3 problem and then we probably go to the next lesson if we have time. Let us see how it goes. So I want to wait for you a little bit to solve this level 3 problem here again. Yourself first. Okay? We have a quadrilateral. Inscriven here means in English inscribed. Okay, inscribed means the vertices are on the circle. Okay, we are supposed to find the biggest angle of this side of this quadrilateral. Yes, oh, between the diagonals, sorry, we want to find the bigger angle between diagonals of a quadrilateral. Yes, so if you have a quadrilateral, not necessarily inscribed, any quadrilateral, if you take this line and connect it to this line, this is a diagonal, and the other diagonal is this one. And then you see that you get 4 angles, but these two are the same, these two are also the same. They want you to find the bigger one for that quadrilateral in that semicircle. Yes, is the question clear? Okay, but by the way, for level 3 problems, understanding the question is also part of the question. Okay, I want to wait for you a little bit so that you can work on it yourself. I mean, this is probably a good problem. Yeah, I mean, yeah, is that understandable what you are supposed to do? You are supposed to draw the diagonals. Yes. This is one diagonal, and the other one is this one. Okay, as I told you, there will be 4 angles here. 2 of them are of the same size because they are vertical angles. 2 of them are of the same size. But one of them is bigger than the other one. You want to find the bigger one. Yes? That is the picture you might draw. Yeah, this is a hard question, I would say. You want to give me the answer?
I think I did.
Yes, just tell me what to do.
I can. You first know that.
So let me give the angle's name. So this one alpha, the bigger one I call alpha beta. Of course, this is also beta, that's alpha. Okay, so we want to find the bigger one. Yes.
Give names to all the other angles as well. The two C angles.
Okay, so let me write X, Y,
And
then
on the other side as well.
this one,
Yes.
Z and W.
I know that W and Y are 90 degrees because it's a half circle, and
Yeah, so let me review. This is a very important fact I want you to remember. That you remember I told you that if you have an inscribed angle opposite to a diameter, that is 90. That is, I want you to remember. If I have any diameter, and if I pick a random point on the circle and connect it to the ends of the diameter, then this angle is always 90 regardless of where I am choosing that point, yes? This is a very important fact. The inscribed angle opposite to a diameter, even if it is above, that's also true. Any point, any inscribed angle opposite to a diameter is 90. So what Hasbulat is saying is that in this picture, W is definitely 90 degrees. Why is that? Because this is inscribed and opposite to a diameter. So W is 90. So if you don't mind, let me just, instead of writing W, clean it and write it 90 degrees. Yes. The same with Y. Why? Because that is also an inscribed angle opposite to a diameter. So that is also 90 degrees, okay?
Now, I know that 71 minus 180 is x plus 90.
71 is?
180 minus 71 is equal to x plus 90. No, 71 plus x plus 90 is equal to 180. But it's the same thing. Because they are opposites and they're inside a circle. 71 degrees.
Yes, 71.
Is opposite to x plus 90.
Yes. So you are saying that this is a cyclic quadrilateral.
Yes, exactly.
That's what you are saying.
Yes.
Yes. It is of course it is a cyclic quadrilateral. Why? Because all vertices are lying on that circle. One part of it is invisible, but we know that's a circle. So yes, if you use that fact, then it means that this angle plus this angle should be 180. Yes, so what is he saying? So that angle is 71 degrees plus, what is this angle? Is x plus 90 degrees. This is supposed to be 180 degrees. And then if I move this to this side, it is 90 left. If I move this to the other side, how much is left? 19 degrees is left. So in this way, Hasbulat was able to find that x. Okay?
I can do the same thing to the other side. 55 plus 90 plus
Yes, because now it is also a cyclic quadrilateral. So 55 plus the whole angle, the same story, yes? 55 degrees plus that angle, but that angle consists of two parts, the z part and the 90-degree part. This is supposed to be equal to 180 degrees. And if you solve this equation, z ought also immediately found, yes? 35, yes. 35 degrees. So that is z and that is x. So now we know x, we know z, and the problem is solved. Is that right? Why? Because now, very good solution, thank you. So this one is what? Is a triangle. Yes? And we know that alpha plus x plus z should be how much in that hatched triangle? 180. I am looking for alpha, but I already know x, I already know z, so I put them there. So alpha plus x is 19 degrees, z is 35 degrees, is 180 degrees. So what is that? Alpha is 20, 55 minus that is 166, yes?
126.
Sorry, 26, yes. 126 degrees. But is alpha the answer? Yes, because we don't know. But we now know that this one is the bigger one, because of course the sum of them should be what? 100, no, the sum of these two should be 180. So if this one is 126 degrees, what is left for B is a smaller. So the question is asking you for the bigger angle, so we don't doubt about it. The bigger angle between these is 126 degrees. So you see, the algebra is not involved. I am not saying this is the only way. Might be you find a different way to solve the problem, but that is also fine. Yes? But I want to tell, let me ask you a question. Can I say alpha is central?
No.
Can I say alpha is inscribed? No, it is neither of them. So you cannot use those theorems directly. Okay? Because alpha is this angle. This angle is not central because the vertex is not the center. It is not inscribed because the vertex is not on the circle. So alpha, beta, these are types of angles that are neither inscribed nor central. So you cannot use those theorems. But at least we use one theorem, and that was the property of a cyclic polygon or cyclic quadrilateral here. Any questions? Yes, so that was a good question. For the next lesson, we don't have time to teach the next lesson. Let us see if there is another problem. Yeah, we can work on this problem. But that one, I don't know why this is level 3 problem. Isn't it the same problem we did before? Show that the sum of the opposite angles in an inscribed, what? Inscribed or cyclic quadrilateral is 180 degrees. Yeah, this is, I don't know why they have asked this question, because that is exactly what we had when I was teaching to you. I proved that to you. So let us not spend time on that one. Let us spend time on this one, okay? These marked sides, these red lines are of the same sizes, yes? We want to show that this angle alpha is 60 degrees. Oh, okay, and if I understand the Swedish correctly, this is mentioned that these are also equal to the radius, yes? Am I right? Yeah, so the red ones are not only equal to one another, but they are also equal to the radius of the circle. And then we want to find alpha. So I will change the picture intentionally because that picture is misleading. You think that if I connect this one to this one, it will passes through the middle. It might passes. It's not wrong for that case, but that is not the general case. So consider that you have a point here, for example. Okay, and then if I connect this one to that one, okay, so let me put it somewhere that you don't feel it is passing through the center. Okay, so for example, let me just draw this one. Oops. And then here, we still want to show that this is 60. So that's important. So you see, this length and that length are equal, and they are equal to the radius of my circle. And then it doesn't matter where I choose this point. Wherever it is working. Then I take this one and connect it here and connect it there. We want to show that this angle alpha is always 60. Okay? And then you see that if I take this one and connect it here, it does not pass through the center. In the picture in the book, you feel that, okay, I take them, they will be, then you mistakenly think that the problem is very simple. The problem is not hard, but I want you to see that this is the correct picture. Yes?
I can say the solution.
Oh, you know the solution. Okay, so let me, I put a double dash here, so they are equal. Okay, so what do you say?
You see the 3 red dots?
Yes?
You can all connect them to the middle.
Is it necessary or not?
Yes, yeah.
Okay, so it means that I take the center somewhere here, hopefully. Yes, and this is my center, which is not on the line that if I connect this one to this one. I want you to understand that. It might be, but that there is no guarantee, okay? But what Hasbulat saying is that connect all these 3 to the center. Okay, so let me follow him. So this is center, I call it O.
Then you have 2 equilateral triangles.
Why it is equilateral? Because it is mentioned, first of all, you know this is radius. This is radius, so they are equal. But why they are equal to this one? Because of what is given in the problem. So it means that if I call the radius r, I can call this r, I can call this r, all of them are of course r. Yes, so this means that this is an equilateral triangle. So this angle is 60, this angle is also 60.
So they are 100.
They are also 60, but we don't need them. Yes, and then of course everything becomes clear. Why? Because this big angle that you see here, what type of angle is this? Central, because the vertex is the center and the arms are radii. So that is a central angle, subtending which arc? Subtending this arc. But this alpha is what type of angle? Inscribed. But it is also subtending the same arc. So the size of alpha, the size of the central angle, should be 2 times the size of the inscribed angle. So the alpha is what? 60. So, I mean, from these problems, I think problem 4217 was the only one which was really level 3 problem. Yes? See, it was very simple. It was not hard. Any questions? Okay, have a nice weekend. Thank you.